Welcome to Creata classes. From this lecture onwards, we will start with medians. We have divided the lectures in medians into following sub-lectures. In the first lecture, we will cover the basic introduction to the medians and the relation between area of triangle and the triangle formed by the medians. In the second lecture, we will cover the relation between the sides of triangle and the medians. It will also include the Apollonius theorem. Third and fourth lecture are the special cases of median. In the third lecture, we will cover the medians of a right angle triangle. And in the fourth lecture, we will cover the triangles having two medians as perpendicular to each other. In the fifth lecture, we will cover the summary of the complete median series. So first of all, we will begin with medians. That is our first topic. Medians are basically the line segment joining the vertex with the midpoint of the opposite side. So this is the median. We can have total 3 medians in a triangle. They have a special feature, that is these medians always intersect at a common point. You can take any random triangles, median will always intersect at a common point. So a small construction experiment for you. Take any triangle, locate the midpoints of the sides of the triangle. Join it with opposite vertices. You will get 3 medians. Observe that these 3 medians are intersecting at a single point, that is a common point. Whenever I told you to do these small construction experiments, you should do it, as these small constructions help you build a strong foundation. Moving further, the common intersection point is called the centroid. This centroid is also the center of gravity of the figure. The ratio of these two parts of median will be 2:1. This is also a special feature of the median, that is the centroid divide the median in the ratio of 2:1. For example, if we take the total length of a median as 9 cm, then this portion will be 6 cm and this will be 3 cm. That is, the ratio will be 6:3, that is 2:1. This is the standard rule. For this figure, AG by GD is equal to 2/1, BG by GF is equal to 2/1, and CG by GE is equal to 2/1. This ratio will help you in solving many questions related to medians. Remember this portion attached to vertex is the larger, that is 2, and this is the smaller, that is 1. A common mistake, in hurry, many times the students take the ratio as inverse, that is 1:2. Remembering technique is that 2 is attached with a line starting from the vertex. A small thing, just a common mistake. Now to check the fundamental, we will go back to our construction experiment figure, okay? Take out your scale and measure these ratios. Are you getting 2:1? Check it out. Okay, now we got the centroid divide the median into the ratio of 2:1, and we have also checked with our experimental figure. I have already told you to do this small construction figure. It will help you clear the fundamental and remember the concept. Those who have skipped the construction, please pause the video and do the experiment and come back with your result. It will really help you in long run. After this small experiment, few doubts may be coming in your mind. Why all the 3 medians are intersecting at a common point? 2 medians are intersecting at a point. The third median can be slightly above or can be slightly below the intersection point. Why it is exactly joining the intersection point? Many students have the same doubt, and the second doubt that would be coming in your mind is, why is the ratio of 2 parts of median is 2:1? As a student, you have the right to ask the question why. It is good practice to go deep into the topic and understand the fundamentals. Let's find out the reasons. Let's take only 2 medians, EC and FB. These medians are intersecting at point G. Let's join A and G, and we will extend the line to meet BC at point D. Here AD is not the median, only EC and BF are the median. Here we have to prove AD is also the median. If we have proved AD as a median, then we can say that all the three medians passes through the same point. Let's do so. We know medians join the vertex with midpoint of the opposite side. If we somehow able to prove D is the midpoint of BC, then we can say AD is the median. So the approach that we will use is, we will prove D is the midpoint of BC, that is BD is equal to DC. Let's extend AD to H such that AG is equal to GH. Both of these lengths are equal. Let's join BH. Are you able to observe ABH as a triangle? Three sides are there. Let's take out this triangle. Here we know AG is equal to GH. Okay, we have extended the line AD to point H such that AG is equal to GH. Further, E is the midpoint of AB, that is AE is equal to EB. Why? Why E is the midpoint of AB? Because EC is the median and medians join the vertex with the midpoint of the opposite side. I will repeat the concept where it is needed so that you will grasp the concept and the fundamentals. By repeating the fundamental many times, you will understand it. Further, for this triangle, we got AE is equal to EB and AG is equal to GH. Are you able to correlate it with the figure of the midpoint theorem? The same we have covered in the quadrilateral portions. As per the midpoint theorem, the line segment joining the midpoint of two sides of a triangle is parallel to the third side and is also half of the length of the third side. So for our triangle, here E and G are the midpoint of two sides of the triangle and EG is the line segment joining the midpoint of two sides of the triangle. So as per our midpoint theorem, EG is parallel to the third side, that is BH, and also EG is half of BH. We only need EG is parallel to BH. Both of these line segments are parallel to each other. Or we can also say that BH is parallel to this complete line segment EC. EG and EC are both the same lines. What we have done, we have taken this triangle ABH and we have proved EC is parallel to BH. In similar line, can we take the triangle AHC and we can say BF is parallel to CH. Same fundamental will also be applicable to this triangle also. Moving further, are you able to observe this parallelogram BGCH? The opposite side of this quadrilateral we have proved as parallel, so we can say this quadrilateral is a parallelogram. Okay, any issue? Here GH and BC are the diagonals of this parallelogram. And we know diagonals of a parallelogram bisect each other. This is the property of the parallelogram. That is BD is equal to DC and GD is equal to DH. Okay. Got the fundamental? This is the property of the parallelogram. Diagonals of a parallelogram bisect each other. BC and GH are the diagonals and D is the intersection point. So we got BD is equal to DC and GD is equal to DH. That is, we have proved D is the midpoint of BC. Getting the point? We have proved BD is equal to DC. That is, D is the midpoint of BC. And the line segment joining midpoint with the opposite vertex is the median. So AD is the median. Okay, we have proved. So we got all the three medians of a triangle meet at a common point. One more point. Here we have also got GD is equal to DH. And we know AG is equal to GH and GH is equal to GD plus DH. So on replacing DH with GD, we got AG is equal to twice of GD. This is the second proof, that is the centroid divides the medians into 2:1 ratio. Got it? So we have proved two things. First, we have proved that three medians in a triangle intersect at a common point. Then we have proved that centroid, that is the common intersection point, divides the median into the ratio 2:1. Okay, got the point? So let's move to the next topic. Before moving further, let's understand a small fundamental. For that, let's take a triangle ABC. Let's draw a line from the vertex A meeting the side BC at point D. For this triangle ABD, the area will be half into base into height. Okay, this is the formula of area of triangle. Here BD is the base and let's take H as a height. The height is the perpendicular distance. So the area will be half into BD into H. Further, let's take the triangle ADC. Area of this triangle will be half into base into height. Let's take the base as DC. What will be the height for this triangle ADC? The height will be the perpendicular distance from the opposite vertex. Okay. So here the same H will be the height for this triangle ADC. Don't be confused that the height is coming outside the triangle. The height can come outside the triangle. Just it should be perpendicular from the base. Okay. And it should join the opposite vertex. So here H is fulfilling this condition. So H is the height for this triangle. So we got the area of this triangle as half into DC into H. If we divide the area of triangle ABD with the area of triangle ADC, we got half into BD into H upon half into DC into H. Half and H will cancel out. We will remain with BD by DC. It means that ratio of area of two triangles with the same height is equal to ratio of their bases. If we assume BD as A and DC as B, that is the ratio of BD and DC is A is to B, then we can say the ratio of area of both of these triangles will be A is to B. It will be same as the ratio of the bases. This is the fundamental that will be used. For further better understanding of the concept, let's take a small example. Let's take a triangle ABE. AC and AD are the two lines which is joining from the vertex to the opposite sides. BC is A, CD is B and DE is C. Here in this figure, are you able to observe three triangles? Triangle ABC, triangle ACD and triangle ADE. The base of these triangles are given as A, B and C respectively. Or we can say the ratio of bases of these three triangles are A is to B is to C. Then the ratio of area of these triangles will also be in the ratio of A is to B is to C. Okay, this is the fundamental. Let's take a small problem. Refer the figure. Triangle ABC is given. BD is a line segment which is joining the vertex with the opposite side. AD is given as 2 and DC is given as 3. And area of triangle ABD is given as 20 cm square. We have to find the area of triangle BDC. Okay, two triangles are given in this figure. If we take AC as a base, we can say the ratio of AD to DC is 2 is to 3. And we know the ratio of area of both the triangles is equal to ratio of their bases. If the height is same and height of both of this triangle is same, so we can say the ratio of area of both of this triangle is equal to ratio of their bases. That is area of triangle ABD upon area of triangle BDC is equal to 2 by 3. And area of triangle ABD is given as 20 cm square. So we got area of triangle BDC as 30 cm square. Why? Because ratio of their bases is 2 is to 3. Okay, got the concept? Ratio of area of triangle will be same as ratio of their bases. This concept we will use. Now come back to our topic, that is medians. Medians we have seen as a line segment joining vertex with the midpoint of the opposite side. Midpoint means ratio of these lengths will be 1 is to 1. If we apply our area fundamental, can we say area of both of this triangle will be in the ratio of 1 is to 1? Both of these triangles are having same height and ratio of bases is 1 is to 1. So we got the median divides a triangle in two equal halves or two triangles of equal area. Similarly, we can say these medians also divide the triangles into equal halves. If you observe, these medians have divided the triangle into 6 equal parts. That is, area of all these triangles are equal, which will be 1 by 6 of the complete area. Okay, got the fundamental? The median divides the triangle into 6 equal parts. To further understand this concept, let's assume area of this complete triangle as 6 square unit. This is our assumption. We know median joins with the midpoint, means ratio of BD is to DC will be 1:1. BD and DC both are equal to each other as D is the midpoint. So as per our fundamental, can we say area of triangle ABD and area of triangle ADC will also be equal to each other? That is in the ratio of 1:1. Why? Because ratio of their bases, that is BD is to DC, is also 1:1. And just now we have covered that the ratio of area of two triangles with the same height is equal to the ratio of their bases. So BD is to DC is 1:1. So area of triangle ABD and area of triangle ACD will also be 1:1. And we have assumed area of this complete triangle as 6 square unit, and area of triangle ABD will be half of 6 square unit, that is 3 square unit, and area of ACD will also be equal to 3 square unit. Further, we also know the centroid divide the median into the ratio of 2:1. If we take only the triangle ABD, can we say ratio of AG is to GD is equal to 2:1? And for both of these triangles, that is triangle ABD and triangle GBD, the bases are AG and GD, and the ratio of these bases are 2:1. So can we say ratio of area of triangle ABG and GBD is also 2:1? And just now we have seen that area of this complete triangle ABD is 3 square unit. So we will divide the 3 square unit into two portions, that is 2:1. So area of triangle ABG will be 2 square unit and area of triangle GBC will be 1 square unit. 2 plus 1, it is 3, and the ratio is also 2:1. Okay, got it? Further, if we take these two triangles, that is AFG and triangle BFG, area of this complete triangle, that is ABG, is 2 square unit, and we know CF is the median, that is F is the midpoint. Okay, so can we say ratio of AF and FB is 1:1? Okay, F is the midpoint. And for the triangle AFG and BFG, AF and FB are the bases, and the ratio of AF and FB is 1:1. So we can say ratio of area of triangle AFG and GFB is also 1:1. And area of this complete triangle is 2. So we can say area of these two triangles will be 1 and 1 square unit. Okay, got it? We have used the fundamental, that is ratio of area of the triangles with equal heights is equal to ratio of their bases. So we got area of these three triangles as 1 square unit, 1 square unit and 1 square unit. Similarly, we can calculate area of these three triangles as also equal to 1 square unit. In the starting, we have assumed area of this complete triangle ABC is equal to 6 square unit. So we got area of all these small triangles as 1 square unit, which is 1/6 of the complete area of the triangle. So we can say area of all these small triangles are equal, that is equal to 1/6 of the area of the complete triangle ABC. This is the fundamental. So we got that the medians divide the area of the complete triangle into 6 equal portions, which is 1/6 of the area of the complete triangle. This is the basics of median. Now we will move to some advanced concept. The concept is the area of triangle is equal to 4/3 times the area of triangle formed by the medians. Firstly, we will see what is the triangle formed by the medians. For that, let's take a triangle ABC with medians as AF, CD and BE. Okay, 3 medians are there. Let's give the name to the medians as A, B and C. Let's take the 3 medians out of the triangle. Can we form a triangle from these 3 sides? That is triangle with sides as A, B and C. This triangle we will call as the triangle formed by the medians. As per this concept, area of the triangle ABC, this complete triangle ABC, is equal to 4/3 times the area of the triangle formed by these 3 medians. This is very important concept, you should remember it. But now the question is why? Why the area of this triangle is equal to 4/3 times the area of the triangle formed by the median? Let's see so. Let's extend the line BE to the point H such that GE is equal to EH. GE and EH both are equal. Let's join A and H. Just now we have studied that centroid divide the median into the ratio of 2:1. So we can say the ratio of AG to GF is 2:1. If complete AF is equal to A, we can say AG is equal to 2/3A and GF is equal to 1/3A. What we have done, we have divided this complete line segment of length A into two parts of ratio 2:1. Complete will be 2 plus 1, that is 3. So the first part will be 2/3 and second part will be 1/3. Okay, the fundamental of ratios we have applied. Similarly, we can say DG is equal to 1/3B and GC is equal to 2/3B. Similarly, this is 1/3C and this is 2/3C. Simply we have applied the fundamental of ratio and proportion and the concept, that is centroid divide the medians into the ratio, that is 2:1. Further, just now we have taken GE is equal to EH and we know GE is equal to 1/3C. It means that EH will also be equal to 1/3C. Further, AE is equal to EC. Why? Because BE is a median and median join the vertex to the midpoint of the opposite side. So E is the midpoint. So we can say AE is equal to EC. If we take the triangle AEH and triangle GEC, okay, two triangles are there. Just now we have seen AE is equal to EC and GE is equal to EH. Both are equal to 1/3C. Further, both of these angles are vertically opposite angle. So we can say angle AEH is equal to angle GEC. So by SAS rule, we can say both the triangles are congruent to each other. Okay, we have proved both the triangles are congruent to each other. So by CPCT, we can say GC is equal to AH, that is GC is equal to 2/3B. So we can say AH is also equal to 2/3B. Okay, getting the understanding? Okay, we have just proved both of these triangles are congruent to each other by SAS rule. For those who have still not completed congruency and similarity, those students to complete the topics before coming to this topic. After understanding the fundamental of congruency only, you will be able to further understand the concept of this chapter. Okay, moving further, we have just proved both of these triangles are congruent to each other, means they are exactly matching each other, which further means that area of both of these triangles are equal to each other. So we can say area of triangle AEH is equal to area of triangle GEC. If we add the triangle of AGE to both the sides, we can say area of this complete triangle is equal to area of this complete triangle. That is, area of triangle AGH is equal to area of triangle AGC. Area of both of these triangles will be equal to each other. Simple. And previously we have seen that medians divide the complete area of the triangle into 6 equal parts. These are the 6 equal parts. So can we say area of these two triangles is equal to 1/3 times area of the complete triangle ABC? Okay, this is 1/6, this is 1/6. On adding, we got 1/3. So we can say area of triangle AGC is equal to 1/3 of the area of triangle ABC. And just now we have proved that area of triangle AGC is equal to area of triangle AGH. Okay, area of both of these triangles are equal to each other. So by comparing, we can say area of triangle AGH is equal to 1/3 of the area of triangle ABC. Okay, getting the concept? Firstly, we have proved both of these triangles are congruent to each other. Then we have proved area of this complete triangle is equal to area of this complete triangle. Then we have seen area of this triangle is equal to 1/3 times area of this complete triangle ABC. I will keep on repeating the fundamental and keep on repeating the steps so that you can understand the steps. Moving further, if we observe the triangle AGH, let's take the triangle AGH out of the figure. Are you able to observe all the sides are 2/3 times the length of the medians? Let's compare this triangle with the triangle formed by the median. The triangle formed by the median is having the sides as A, B and C, and this triangle AGH is having the sides as 2/3A, 2/3B and 2/3C. That is medians into 2/3. Can we say both of these triangles are similar to each other? Their ratios of corresponding sides are equal. And we have done the theorem in the similarities of the triangle. That is, if two triangles are similar, then the ratio of the area of both the triangle is proportional to the square of the ratio of their corresponding sides. And both of these triangles are similar. So can we say area of triangle AGH upon area of triangle formed by the median is equal to 2 by 3a upon a whole square, which is further equal to 2 by 3 upon b whole square, which is further equal to 2 by 3 c upon c whole square. That is, area of triangle AGH upon area of triangle formed by the median is equal to 2 by 3 whole square. That is 4 by 9. And just now we have proved area of triangle AGH is equal to 1 by 3 times area of the triangle ABC. Let's replace so. On solving, we got area of triangle ABC is equal to 4 by 3 times area of triangle formed by the medians. This is the proof of the concept. So we got that area of triangle ABC is equal to 4 by 3 times area of triangle formed by the medians. This is very important concept, you should remember it. And now you have understood that how we got this formula. Let's take a small question based on this formula. The medians of the triangle is given as 3, 4 and 5 centimeter. We have to find the area of this complete triangle ABC. So firstly we will form a triangle with the sides which are given as medians. Okay, 3, 4 and 5. Are you able to observe 3, 4 and 5 are Pythagoras triplet? That is, these will form a right angle triangle. Let's make a right angle triangle with sides as 3, 4 and 5. 5 is the hypotenuse and 3 and 4 are the legs of the triangle. Let's find the area of this triangle. Area of the triangle will be equal to half into base into height. That is half into 4 into 3, which is 6 centimeter square. Okay, so we got area of this triangle, that is the area of the triangle formed by the median, as 6 centimeter square. Further, we have to find the area of the complete triangle ABC, and just now we have proved the relation, that is area of triangle ABC is equal to 4 by 3 times the area of the triangle formed by the median. And we have calculated the area of triangle formed by the median as 6 centimeter square. So we got the area of triangle ABC as 4 by 3 into 6, that is 8 centimeter square, which is the answer of the question. Very interesting formula. Many questions are generally asked based on this formula in the competitive exams. So you should know this formula. So that's it for this lecture. Thank you very much for being with Creata classes.